Hello and welcome to another video lab. Though this is more of an activity to kind of like enrich and learn something versus just doing like something we've already learned about and doing a lab report. So lab activity, what we're going to be talking about today is we're going to make some connections between that DA stuff we've been doing and actually now some chemistry. So I'm going to turn my computer so that you can see my lab setup. So you're going to hear my voice and see me working, but you're not going to see my face for the rest of this lab. So you can pretend it's your own hands actually doing the lab activity. Real quick though, if you've not already done so, you need to open up this document because you're going to fill this in actually with me to learn this new information, something about DA, but something about molar mass and elements and some stuff we don't really know about yet. That's what we're going to learn. So if you've not already opened this document, pause this video, go open this, and then come back and let's get into it. All right, so now you should be able to kind of see my setup here. You can see I've got a balance. I've got a calculator, so you might want to grab one of those. I've got my sample that we're going to be talking through. And then, of course, I've got my lab handout. So let's go ahead and follow along and read with me. It says, today you're going to be using DA connected with chemistry and lab work, which is really the whole point of knowing DA. So it's not just random math, but it's actually connected to chemistry. Aluminum is going to be our focus. Today we are going to use aluminum as an example. The things we will learn about aluminum today can be applied to all other elements on the periodic table in connecting DA to a very important concept called the mole. Okay, what do we know about aluminum? Is it a metal or non-metal? Well, we take a look at our periodic table. We've got this dividing line. Aluminum is on the left, so that means that it is a metal. So fill that in. Atomic number. Now, this has been a while since we've talked about atomic number. So remember, atomic number is the number that defines the element, and it's the one that goes in order. So aluminum's atomic number is 13. The atomic mass is the number that has a decimal with it. So on this very little periodic table, you can see it. So I'm going to go to 2 decimal places, which is pretty normal when we're doing our chemistry things. So 26.98, and I'm going to fill that in, 26.98. And then it asks for the number of protons. Again, just kind of a quick review. Well, remember, a proton is what identifies the element. The atomic number is also what identifies the element. So that is the number of protons. So those are some things that we know about aluminum. All right. Continuing on. Take a look at what you wrote for atomic mass. Rewrite it here. 26.98. Go ahead and write that again. Okay, but I've got a problem with that because it's a naked number, and I don't like naked numbers. So what are the units of atomic mass? Well, the word mass, maybe you've heard of this from other places. Mass maybe would make you think of grams. So that's my sort of random guess, like maybe it's grams. And you would be close, but it turns out that the scientists that figured out that number on the periodic table gave it a unit called atomic mass unit, AMU. So we measure atomic mass in atomic mass units. Okay, so we can now clone that number. So what is the atomic mass of aluminum? 26.98, but now we can put AMU. So now it's not a naked number anymore. All right, but we still have a problem because AMU doesn't really mean anything to us. We don't have an AMU setting on our balances. We can't measure out 34.33 AMUs. But it turns out that scientists have said that 1 AMU equals 1 gram/mole. There it is, that word mole. Well, what the heck does that mean in chemistry? The mole is a way to group lots of teeny tiny things together. It's a word like a dozen or a gross of something. Only it's used at the atomic level because since atoms are so small that even a gram or even a microgram just aren't very useful. We'll talk a lot about the mole later. For now, we just need to realize that we have a new conversion to use, and it is one that explains some things about the elements on the periodic table and relates that information to something we can actually use in the lab. Okay, go ahead and turn to the next page. So, using the new label from part 4E, rewrite the atomic mass for aluminum. Okay, so look back at 4E. So 4E is where we learned that if you have 1 AMU, that's 1 grams per mole. So if I have 26.98 grams per mole, or if I have 26.98 AMU, that would be 26.98 grams/mole. So fill that in there. 26.98 grams /mole. So that is now my new thing. So what that really means is I have 26.98 grams for every 1 mole of aluminum. That number of grams in 1 mole of an element is referred to as the molar mass of that element, the mass of 1 mole, molar mass. Okay, you take that definition and put it in your own words. So you define molar mass. So you're doing this part right here. Okay, I'm not going to give that to you. So I want you to put that in your own words. So think about what we just did. Pause the video if you need to. So the number of grams in 1 mole of an element is referred to as the molar mass. So give that definition in your own words. Okay, welcome back. Here we go. Number 5. Let's go back and talk about aluminum and this new idea of molar mass. What is the molar mass of aluminum? Go ahead and fill it in here, but write it as a ratio, like when you set up DA problems. So I'm going to say that there's 26.98 grams of aluminum for every 1 mole. But since these two numbers are equal to each other, I can flip the conversion and I can write it as 1 mole of aluminum over 26.98 grams per aluminum. Again, scientists sometimes use the term mole to refer to elements and compounds because there are so many tiny particles packed into 1 mole. It's just like saying it's easier to order 4 dozen roses instead of 48 roses. Only the difference is more drastic when using moles since we are dealing with tiny atoms. But since mole is again something that isn't very practical in the lab, we need that molar mass conversion to turn moles into something that is useful because molar mass can be used to convert moles into, what is it? Grams! Hooray for DA! And then grams is something we can actually measure. All right, we're on number 6. Now it's time to do something with all this information. So I'm going to use a balance, and I'm going to mass out 1 mole of aluminum. Oh, wait a second, but my balance only measures in grams. It says error because I picked it up. So it measures in grams. So how can I measure a mole if this measures in grams? Oh, wait a second. We just learned that 1 mole is 26.98. So I'm going to take my weigh boat. I'm going to hit 0 so it cancels out the mass of the weigh boat. And then I'm going to put some aluminum. This is safe for me to touch. And I'm going to put some in there until I've got about 26.98. Now, I might not be able to get exactly 26.98 because of the pieces and the size that I'm dealing with, but I'm going to try to get really close. So 26.98. All right, let me see if I can take a small piece out because I'm a little bit too high. So this is 26.62. So this gives you a visual now of what does 1 mole look like. Well, this is what 1 mole of aluminum looks like. And I'm going to label that 1 mole. So then I've got kind of a visual of what 1 mole of aluminum looks like. So 1 mole looks like this. So we've got our reference piece here. All right. Now, again, that exact mass was 26 point, oh, I don't remember what it was. I got to look here. Put that back on there. 26.64 technically is what I have. That's approximately the 1 mole. All right. So that's my sample size for 1 mole. Now I'm going to use the balance and measure out approximately 35 grams. All right, so again, I take a weigh boat and I zero it out. So now that subtracts the mass of the weigh boat. And then it just asks for 35. So I'm going to put something close to 35. And again, it's safe for me to touch these little pieces of aluminum. So we're going for 35 was the goal. Oh man, I'm so close. I'm going to put one more piece in there. All right, and then it says record the exact mass. It says 35.42. 35.42, can you see that? All right, so then it says record the exact mass. So I did that. So we're at the bottom of that page. Are you with me here? Okay, so now go to the next page. Compare this sample, so this new sample from 6A, to this sample to the sample in our first one. So we've got our 1 mole sample, and then I got this sample. Let me get them both in here. Why is this so hard? There we go. Okay, so take a look at these 2 samples. Based on your observations, would you expect this sample, this one, to be equal to 1 mole, more than 1 mole, or less than 1 mole? Sorry, I'm trying to hold them so you can actually see. All right, so from those 2 examples, all right, you made your prediction. So you made a prediction. You filled in one of these. So is it equal to 1 mole, more than 1 mole, or less than 1 mole? Let's see if you're right. Using DA, calculate the number of moles of aluminum from the grams we had in 6B. So I'm going to start with this number as my given, 35.42. So start with that. 35.42 grams of aluminum. We're doing DA. So this is like those problems we did before with like the Halloween candy and like all the other stuff. 35.42 grams of aluminum. But I wanted to know, is that equal to 1 mole, more than 1 mole, or less than 1 mole? So I've got to get to moles, which means I have to cancel grams. Okay, so wait, I have to cancel grams to get to moles. Oh yeah, that's this conversion, right? So I need to cancel grams and get to moles. So I'm going to set up my problem using this version of molar mass. So I'm going to put the 26.98 grams on the bottom, 1 mole of aluminum on top, because look, then grams will cancel. I'm left with moles, which is what I'm trying to figure out, because again, I'm trying to see if my prediction was right. So now I'm ready to calculate. So we get our calculator here. 35.42 divided by 26.98. All right, so that gives me, now let's talk sig figs, right? So I can keep 4 sig figs, so I can keep the 1.312, but then after the 2, there's an 8, so that's going to round up to a 3. So 1.313 moles of aluminum. So just making sure we're in agreement here. This is using DA with our new conversion molar mass. So more than 1 mole, were you correct? So just a yes or no there quick. All right, so now we've got this idea. Oh yeah, because 1 mole was about 26.98 grams, right? And then this, remember, was 35. So it makes sense that that was a higher gram sample. Okay, and then it says that I can place this sample back into the beaker. So I'm done with that one. Now it says use the balance and measure out approximately 9 grams of aluminum. All right, so I get my zero out my weigh boat so that I just get the mass of the aluminum. And this time it only wants 9 grams. See if I can get that pretty close. 9 grams, a couple more there. How about 1 more? All right. Okay, and then can you see what that says? Go ahead and record the mass there. Can you see it? 9.77. Make sure we can still kind of see stuff here. 9.77 grams. All right, so then we've got our 1 mole sample, right? And then now we've got this new sample. All right, so once again, make your prediction. Is this new sample going to be equal to 1 mole, more than 1 mole, or less than 1 mole? Make your prediction there. All right, so you made your prediction. So you just did your prediction here. Let's see if you're right. Using DA, calculate the number of moles of aluminum from the number of grams. So 9.77 grams of aluminum. And once again, so I'm setting up my problem. I want grams to go away because I'm trying to see if my mole prediction was accurate. So I'm going to use that same conversion I used up there, 26.98 grams for every 1 mole of aluminum. Grams will cancel. I'm left with moles, which is what I'm trying to figure out. So I'm ready to equal. And then this time I go 9.77 divided by 26.98 equals, all right, so you get this on your calculator, but once again, I can only keep, this time I can only keep 3 sig figs. So this has 4 sig figs, but this one only has 3. So it's less of a measurement. So that means I can't be quite as specific in my final answer. So I can keep the 0.362. I look at the next number for rounding. It does not round. So 0.362 moles of aluminum. All right, so then that ends up being my answer. So then were you correct? Less than 1 mole? All right, so then that made sense because first of all, you can see like how few there is because remember 1 mole is about 26.98 and this is only about 9. So again, trying to make a connection between something we can actually see and now this new thing called a mole. All right, okay, so that mole sample was kind of set over there. Now we're on number 7. Now it's time to do something else with this brand new, wonderful, delightful conversion called molar mass. Wait a second. What was molar mass again? Go ahead and write it down. What was molar mass? What did that mean? Oh, yeah. The amount of grams equal to 1 mole. And we got that number from the periodic table, remember. Okay, so then it says we're on 7B. It says use the balance to measure out 2.9 moles of aluminum. All right, so I get my weigh boat. And I put it on there, and wait a second, my balance doesn't measure in moles, so how am I going to measure out 2.9 moles of aluminum? All right, go ahead and flip the page. Okay, so wait, there's a problem. Moles isn't very useful, or isn't a very useful measuring unit, but we can fix that by using what? Think about that thing you just defined. Yeah, molar mass. So I can use this idea of molar mass as a conversion. So I'm going to start with my 2.9 moles of aluminum and turn that into grams. So 2.9 moles of aluminum. So this time, when you set up your conversion, I need moles to cancel. So think about where it needs to go. Yeah, it's got to go on the bottom. So 1 mole of aluminum goes on the bottom, and then that's always equal to 26.98 when we're talking about aluminum. If we were talking about a different element, that number would change from the periodic table, but we're still talking about aluminum. So moles goes away. I'm left with grams, which is what I need to be able to measure 2.9 moles. So I'm ready for my math problem. Ready? 2.9 times 26.98. Okay, so I get this number, 78.242, but I can only keep 2 sig figs because of that 2.9. So that's going to round to 78 grams. So I'm going to now go to the balance, and I'm going to measure 2.9 moles of aluminum, which remember is really 78 grams. Let's see how close I can get it to 2.9 moles. So here we go. 29. I need a bunch of them, so I'm just going to dump them in there. Says I'm trying for 78. Oops, got a few too many there. All right, let's try that. So I'm trying for almost, oh, look at that. Okay, so 78, can you see it? 78.04. So really close. All right, now look at this sample. Remember, this is what 1 mole looked like. Now look at this. This is so much more. Well, that makes sense because remember, this was 2.9 moles and this is only 1 mole. So kind of giving you that visual of what do these numbers really mean. And then last one it asks me is, it says I can get rid of this sample. So put the sample back in the beaker. And then now I'm on letter G. Use the balance to measure out 1.2 moles of aluminum. All right, well, once again, we can't measure in moles on our balances, so we're going to use dA to calculate how many grams of aluminum are in 1.2 moles. So start with 1.2 moles, so you've got your given there, and then now we need moles to cancel, so I'm going to put 1 mole on the bottom, 26.98 grams on the top. Moles will cancel, which is what I wanted because I want to get to grams so that I can use my balance. So then now I'm ready for my calculator. 1.2 times 26.98 equals, so I get that on my calculator, but remember, I can only keep my 2 sig figs. So I'm going to round it off to 32 grams of aluminum. So that's what I end up with for my sig fig answer. And now I'm going to go to the balance, make sure that's zeroed out, and I'm looking for 32 grams. 32, get that in there. Maybe one more. All right, so can you check that out? So the balance there, so 32.40 it looks like. All right, so then we see that these two piles are pretty close to each other because remember, this is 1 mole and this is 1.2 mole, so just a little bit bigger. So it makes sense that these two piles are pretty close to each other. So what you've done now is you've gotten to see a bunch of different things related to the mole and this new thing of molar mass specifically for aluminum. So now what I want you to do is I want you to finish the rest of this handout thinking about other elements. So apply the same idea where you get the number from the periodic table of the different elements, you take the atomic mass, and you go to 2 decimal places like we did with 26.98, that was just the number for aluminum. So whatever element it is, you take that number, 2 decimal places, and then you do whatever calculation it's looking for, all right? So you're gonna finish the last page on your own and then submit this, and now you know what the mole is, and you know some more stuff about dA and using something from the periodic table and making that connection between math and chemistry and the periodic table. All right, thanks so much for being my lab partner today. Finish up this assignment. Let me know if you have any questions. Bye.